Okay guys, welcome again to my channel. In today's video we'll be looking on the vector multiplication, and under this vector multiplication we'll be looking at the dot through. So if you are new to this channel, you can click on the subscription button and hit up the notification bell so that you get notified anytime I release videos on maths. So before we go into the dot through in vector multiplication, so what is vector, if I may ask? Okay, let me give you a simple definition. A vector is a quantity that has both magnitude and direction. The direction there is what differentiated it from a scalar quantity. So scalar quantities are quantities that always has magnitude but no direction. So magnitude in terms of sizes and lengths, while direction in terms of specific place or in terms of specific cardinal points. So if we are looking at the dot rule in mathematics, vectors are furtherly simplified into two parts, which are the product rule or the vector cross rule, and the dot rule. The dot rule is signified with a dot, and under this dot rule obeys some principles and some rules which differentiated it from the cross rule or the vector rule or the cross product rule. So but before we go further, remember we give a definition of the vectors, and we forget to give examples of vectors. Examples of vectors are acceleration, displacement, velocity, and etc. Then scalars are distance, time, and speed. Speed, distance, and time are examples of scalar quantity. They only has magnitude but what? No direction. So let's see how we can deal with some of the dot rule. But before we move on to solve this nice exercise or this nice challenge, we are going to give some rules on vectors, on dot rule. So one of the rules in dot rule, while applying the dot rule in vector or dot multiplication in vector, says I dot I is equals to 1. J dot J is equals to 1. K dot K is equals to 1. Then if you are having K dot J is going to give us 0 according to the rules of vector dot through multiplication. J dot K is equals to 0. K dot R is equals to 0. J dot R is also equals to 0. So these are the rules. So I dot I is equals to 1, J dot J is equals to 1, K dot K is equals to 1, and J dot K is equals to 0, K dot I is equals to 0, and J dot I is equals to 0. Then before we go again, if you want to look for angles in scalars, if you want to look for angles using the scalar way, or using this dot rule is also called the scalar multiplication. This I forget. The dot rule is also called the scalar multiplication. In case the word dot is not there, if the word scalar is there, it also represents the dot. So scalars can also substitute dots. So one of the dot rule for looking for an angle, if something is given to you like this, you can say A dot B is equals to the magnitude of A, the magnitude of B, multiply with your cos theta. So this is how you can get the angle. So if you use scalar, remember this is a form of this sign here is dot, which we are going to introduce in course of this study. So at the end of the study, at the end of this calculation, we are going to look for the angle. So the first thing we are going to do, applying all these rules, so we are going to bring down our A. If A dot B is equals to this, I will know our A to be 2I plus 2J minus K dot, right? 3I minus 6J plus what? 2K. We close the brackets. Applying the dot rule, there's two ways we can apply the dot rule. By multiplying I with I, multiplying J with J, then multiplying K with K. You can easily resolve it that. But I just want to apply this rule in order for us to understand the purpose of me bringing out all these rules. So if we want to do that, we can say A dot B is equals to, open brackets, 2 times 3 is going to give us 6, right? We are putting 6. Then I times I is going to give us what? 1. So 1 times 6 is going to give us 6. So we have resolved that. Coming to this one, this 2 times minus 6 is going to give us minus 12, right? And minus 12, right? I times j is going to give us what? I times j, or j dot I is going to give us what? 0. So 0 times minus 12 is going to give us 0. So I'm going to put plus 0 there. So move on to the next one, k. 2 times 2 is going to give us 4, right? So we can simply write the 4 somewhere. Then I times k is going to give us what? K dot I. I'm using the word times. It's not ought to be times, it's just dots. I'm going to represent it with dots. So 2 multiplied with this is going to give us 4. And I dot k, or k dot I, is going to give us what? 0. So 0 multiplied with 4 is going to give us what? Plus 0. So we are done with this. We are coming to the next. 2 multiplied with this is going to give us 6, right? J dot I is going to give us 0. So 0 multiplied with 6 is going to give us 0. So we are putting plus 0 there. So we are coming to this one. 2 times minus this is going to give us what? Minus what? 2 times minus this is going to give us minus 12. And j dot j is going to give us what? J dot j is going to give us 1. Minus 1 times minus 12 is going to give us what? Minus 12. So coming to k now. 2 times 2 is going to give us what? 4. And j dot k is going to give us what? J dot k is going to give us what? Equals to 0. And 0 times 4 is going to give us what? 0 plus 0. So we are going to do the same thing for this other one. 2 times this is going to give us 4. And j times k is going to give us what? 0, which is this 0. So coming to this last one. Minus 1. Remember there's a coefficient here, 1. Minus 1 times 3 is going to give us what? Minus 3. And k dot I is equals to 0. 0 times 3 minus 3 is going to give us what? Plus 0. So coming to this other one, minus 1 times minus 6 is going to give us positive 6, right? Positive 6. Then k dot j, j dot k is equals to 0. So 0 times positive 6 is going to give us what? Plus 0. Then coming to this last one, minus 1 times 2 is going to give us minus 2. K dot k is going to give us 1. So minus 2 times 1 is going to give us what? Minus 2. So what are we left with? So our a dot b is equals to 6. 6 plus 0 plus 0 plus 0 is going to give us 6. Minus 2 is going to give us minus 12. Plus 0 minus 2 is going to give us minus 2. Right? So putting this, our a dot b is equals to 6 minus 12 is going to give us minus 6. And minus 6 minus 2 is going to give us what? Minus 8. Okay. If we just apply just this straight way, this multiply with this is going to give us 6. Then this multiply with is going to give us minus 12. Minus 12 plus 6 is going to give us what? Minus 6. Okay. Then this multiply with this is going to give us minus 2. Minus 6 minus 2 is going to give us what? Minus 8. So your a dot b is equals to 8. So thank you very much. So if you find this video useful, you can click on the subscription button and hit up the notification bell so that you get notified anytime I release videos on mathematics. So by the time you are done doing that, you can write down on the comment section below saying I have subscribed and I have hit on the notification bell. God will love you for that. Remember, God loves you, and the people of Bright Brain City Grass loves you, and we all love you, and we all love to see you in our next video again. God bless you, and Jesus loves you. And lest I forget, in my next video, I'll be working on how you can resolve two vectors using the cross product method or the vector method. Using the cross product method. And the cross product method, let me just give you a clue. The cross product method is represented by A multiplied with B. This is actually what makes it different from this. And this cross product method, we are going to be using a determinant on it. So thank you and bye for now.